Okay, so let's talk about what is electric potential difference. So now remember when we are talking about electric potential, now let's say this is a charge, okay, let's say it's a positive charge, and let's say this is infinity. So we will define the electric potential at a point in the field, let's say at point A here, as the work done in bringing unit charge, which means 1 coulomb of charge, from infinity to point A, right now. So let's call it WA lah. Now if I have another point called point B, then the electric potential at B will be the work done in bringing unit charge from infinity to point B, right now. So it's the WB lah. So so what is the difference between the potential at A and the potential at B? So that's called electric potential difference. So if potential at A is defined as work done in bringing unit charge from infinity to A, potential at B is defined as work done in bringing unit charge from infinity to B. So the electric potential difference between A and B will be the work done in bringing unit charge from A to B. So that is the definition of potential difference. Or you can call it work done per unit charge to move a charge from one point to another. It's the same lah. Or you can call it work done in bringing unit charge from one point to another lah. Alright, from one point to another. So what's the difference here? Your formula is also V equals to W over Q. But for your formula for your potential is also W over Q, right now. So what is the difference between potential difference and potential? The difference is in the W. In potential difference, this W represents work done from one point to another. In potential, this W represents work done from infinity to a point. So potential is for a single point. Potential difference is for difference between 2 points. So therefore, what is the significance here? So if the W here represents work done in bringing unit charge from one point to another, now the work done to bring the charge from one point to another is also your change in energy, because when you do work on the charge, you will have a change in energy, either it's gain or loss in KE or PE. So therefore, by modifying the formula, you will get W, which is this one, equals to QV. So it could be gain KE gained by the electron or KE lost by electron equals to QV, because you just bring the Q over. Or it can be gain or loss in PE, also W equals to QV. So usually if you lose KE means you gain PE lah. If you gain KE means you lose PE. So you can use this formula W equals to QV. Now in addition, if you want to find the speed, so let's say you release an electron for, let's say at rest from the negative plate here. Okay, let's say you release an electron at rest from a negative plate, it will move towards the positive plate right now. So let's say you wanted to find the speed here when it reaches this plate. We can play around with this formula, W equals to QV, because W is the gain in KE right now. So W will be the final KE, half mv squared, minus the initial KE, which is 0. Now most of the time the question will start from rest. So then equals to QV. So you can find the speed of the electron when they reach this plate. So to find the change in energy, we use W equals to QV. To find the speed after being accelerated, then we use this formula. But if in the event that your charge did not come from rest, it came from a certain speed, then it will be half mv squared, the higher one, minus half mv squared, the lower one. Alright, so that's how you use this formula. So this formula, W equals to QV, and half mv squared equals to QV, is very useful. And when do we use it? Whenever we talk about a charge experiencing a force in a field and starts to move. Alright, so then you will use this formula. So for example, let's say you have the voltage, let's say it's given to you, maybe this is 12 volts, okay, positive 12 volts, and this is 0 volts. So the V that we are using here is the PD, which is 12 minus 0. If let's say this is 12 volts, this is 4 volts, then the difference is 8 volts. So we substitute as 8 volts. Understand? Alright, so that's how we use this.